The problem is, show that if G circle F is onto, then G is also onto. What is an onto function? So if each B is an element of B, there exists at least one A is an element of A such that f of A is equal to B, then f is an onto function. It is also called surjective function. Here is a diagram showing an onto function. Set X is containing the elements 1, 2, 3, and 4, while set Y is containing the elements D, B, and C. So 1 corresponds to D, 2 corresponds to B, 3 corresponds to C, and 4 corresponds to C. All the elements of set Y correspond to the elements of set X, so this one is an example of an onto function.
Now let's determine if each diagram is an onto function. You have 10 seconds to answer. Not onto, because one value on the right does not correspond to any value on the left. Not onto, because one value on the right does not correspond to any value on the left. They are onto because all values on the right correspond to a certain value on the left. Going back to the problem, let us show that if G circle F is onto, then G is also onto. Suppose F is A to B and G is B to C are functions. Suppose that G circle F is onto, let Z be an element of capital C. Since G circle F is onto, there exists an X that is an element of capital A such that G circle F of X is equal to G of F of X equals to Z. Therefore, if we let Y equals F of X that is an element of capital B, then G of Y is equal to Z. Thus, G is onto.